Hi, everyone. This is solution of problem number 9 on the homework. So we have a hammer. It's got a weight of 5 newtons, and it's supported by 2 cables. The cables are wound around drums. We have some winches, and one is electrically powered, one is hand powered or manually powered. And basically, we need to solve for the tensions in the 2 cables. Hey, I'm going to go ahead and turn that problem statement down so it fades into the background a bit. And zoom in. And our first step, of course, is going to be our free body diagram. We're going to want to isolate node B. And we can't see exactly what it is. It looks a little bit like a movable pulley that's sitting on top of the cable. It also could just be a metal ring that's holding the connection together. Either way, I'm going to want to draw that node and draw the cables for a small distance. This is where I'm going to have my cut line. One of these is going to be cut. And if you want to put a little pair of scissors there to remind yourself that these tension forces are internal, feel free to do that. And now I'm going to draw in the internal forces at this angle of inclination. So we have this one, and we have this one, and we have this one. I'll call this one TBC, T for tension. I'll call this one TAB and label this one as 5 newtons. I'm going to use my triangle that's given. So I have a 5, 12, 13 triangle. And that's going to tell me the ratio of the components of TBC to the hypotenuse. And with that, I'm going to take that layer off and start working through the problem. I'll break TBC into its components into this little bounding box. And I do need them both to be poles. Need them both to be poles. And at that point, I'm not thinking about the source vector, just the components. And I'm going to use the ratios of the triangle to say that the vertical leg is equal to 5 over 13 TBC, and the horizontal leg is 12 over 13 TBC. Okay, I've got 2 unknowns. I can use my equation. Sum of forces in the x direction equals 0. Sum of forces in the y direction equals 0. And solve this kind of using a standard procedure. There's a shortcut for this one. We've only got 4 unknown forces as we look at the 2 components and the other 2 forces here in the system. So you could also do this a little faster. And what I'm going to do here, is remove these labels. And make them just barely. You can just sort of kind of make them out. All right, I'll put a layer on top, and I'm going to use pink to draw on this layer. So I'm going to look at my vertical force equilibrium. And I know that these 2 forces have to be equal and opposite. And so this vertical force is just 5 newtons. To find the horizontal force, to find this horizontal component, I just use the ratios in the triangle. So I say 5 divided by 5 times 12 equals 12. And so this is my 12 Newton force there. Now I can do summation of forces in the horizontal direction to get 12 newtons here. And for my final answers, TAB equals 12 newtons of tension. And the tension member BC equals, I just need the component force. So I could take 12 divided by 12 multiplied by 13 and get back up to 13 newtons of tension there. That's the fastest way to solve this one. Thanks for tuning in.